Good morning, children. Today we are going to discuss electrical power of a circuit. So what do you mean the electrical power of a circuit? Rate of electrical energy supplied to maintain the flow of electric current through a conductor is called as electrical power of a circuit. How we can calculate it? So let's see, we consider a conductor, and this conductor is connected to a battery to maintain the electric flow through the conductor. And the battery has a potential difference V. So then the potential difference V is applied across this conductor, then an electrical current I will be flowing through the conductor. Okay, I. So this conductor has a number of free electrons in it, and these free electrons are randomly moved inside the conductor, and in order to maintain this electron to flow in a particular direction, we have applied a potential difference across the conductors, and the potential difference is V. But how this applied potential difference can make electrons to move in a particular direction through the conductor? So we know that these free electrons are there, they are randomly moved inside the conductor. So, and what are free electrons? Free electrons are the electrons separated from an atom at normal temperature. Okay, and these free electrons, they are randomly moved inside the conductor. But when a potential difference is applied across these two conductors, what happens? This negative terminal of the battery will repel these electrons which has the negative charge, and the positive terminal of the battery will attract these electrons towards the positive terminal of the battery. So what happens? And this attraction and repulsion towards the electron make a organized flow of electrons along the conductor, and so an electric current will flow that leads to the flow of electric current in the conductor. Then what is electrical power? This potential difference is applied here to maintain this flow of free electrons. So in order to flow the free electrons through a conductor, it requires energy. Okay, it requires energy. Simply it cannot flow through the conductor, but it requires energy. And from where this energy is obtained? From the applied voltage here. Okay, and this applied due to the applied voltage, an electric field is produced inside the conductor, and that due to the electric field produced inside the conductor exerts a force on negative particle, that is the electrons, and that force makes the electrons to move through the conductor, so that leads to the flow of electric current through it. So the electrical power, the rate of electrical energy, that means rate of electrical energy means the flow of electric current per unit time is called as, that is rate of electrical energy. So we can write electrical energy E is equal to, or power, electrical power P is equal to W divided by time. And what is W? W is the work done here. So there are two terminals of the battery which are connected to the two ends of the conductor. So the potential across the ends of the conductor are different, and so we have an equation already. The potential difference at the end V, but there is a final potential, and the potential at the end A, VA minus VB is equal to WAB. That means the work done across these two ends A and B divided by the total charge moved Q. This equation already we have. Then the difference in the potential at the ends A and B. Suppose this end is taken as A and this end is taken as B. Then there will be the difference in the potential, and that difference in the potential. What is the difference in the potential? That difference in the potential is the potential applied here through a battery. Okay, so VB minus VA will be equal to the potential that we applied here across the ends of the conductor, that is V. So this equation we can write as V. Then what is VAB? VAB is the work done across these two ends when the electrons moves. So therefore we can write as W, and Q is the total charge moved. Okay, and now from this equation we can get the value for W. Then what is the value of W then from this equation? W is equal to what? V into Q. We will get V into Q. And this value of W we can substitute in this equation, the power of electrical power of the conductor. So we write, therefore we can write V is equal to, instead of W what we will write? V into Q divided by time. And in this equation, V is the potential difference and Q is the total charge moved, and T is the unit time or the time taken to move the electrons from one end to the other end of the conductor. And now here the Q by T. What is Q by T? And Q by T already we have, that is the charge moved per unit time. The charge moved per unit time along a conductor is known as electrical current. I is equal to Q divided by time. We already have. And instead of this equation Q by T, we can substitute this equation I, that is T is equal to, so therefore this equation can rewrite as V into I. So we can get the electrical power P is equal to V into I. So also as per the Ohm's law, okay, as per the Ohm's law we know that V is equal to, okay, what is Ohm's law says? Ohm's law says V is equal to I into R. And if we substitute this equation, the value of V in this equation, what we will get? We will get P is equal to I into R. That means I square R. And also we will get I square R. Okay. And the same equation as per the Ohm's law. So we know that what is the value of I, and if you get the value of I is equal to V by R, right? So the same equation we can substitute in this equation. Value of R also can, I also can be substituted here. So what we will get? So this is the one equation for the electrical power, and this is the another equation for electrical power. And if we substitute the value of I as per the Ohm's law, we know that I is equal to V by R. And if we substitute the value of I in this equation, what we will get? Therefore, we can get the value of electrical power P is equal to. So what we will get? V into V by R. That means P is equal to V square R. So these are the three equations for the electrical power. Okay. What is the significance of these three electrons? So if we have the value of potential and the electric current, you can calculate the value of electrical power. The same way, if you do not have the value of potential difference, and if you have the resistance of the conductor and the value of electrical current, then you can calculate the electrical power of a circuit. The same way, if you do not have the value of electrical current I, then if you have the value of potential difference and the resistance, then you can calculate the power of a conductor. Okay, so these are the three equations for the electrical power of a conductor. So the electric power of a conductor or a circuit or a device is normally measured by watt. Okay, that's the SI unit of watt is the unit of electric power of a device. And sometimes if the power of a device is calculated within 1 hour, okay, normally the electrical power consumed at our home is normally calculated per hour. Okay, so there's another unit. So we know that 1 hour is the universal unit of electrical power. So also another unit is also used to measure the power. So that is horsepower. That is another unit. Then what is horsepower? 1 horsepower is equal to 746 watt. Okay, 1 horsepower is equal to 746 watt. So normally the power of a electrical pump or motor, then again the power of an engine of a vehicle, motorcycle or car or any vehicle, they are normally measured in horsepower. So when you see the specifications of those engines, we can see that the power of that engine is written as in horsepower. So 1 horsepower is equal to 746 watts. The next term is electrical energy. So what do you mean by electrical energy? Electrical energy is the total work done in maintaining the current in a conductor by a voltage source. So as I said, the previous diagram also we have seen that a conductor is connected to a voltage source, that is V here, and the total work done, okay, the total work done for maintaining the flow of current through the conductor through a voltage source. And what is the voltage source? The V, the battery that we applied. The applied potential difference is the voltage source here to maintain the flow of current through the conductor, as we have already seen. And the work done, how much work has to be done for maintaining that current flow through the conductor, that gives the electrical energy of a conductor. From the equation, electrical power that we have already defined or derived, that is P is equal to work upon time. Okay, so in order to get the electrical energy, P is equal to work upon time, and from this equation the electrical energy is what? Electrical energy is the work done. Okay, then that means the electrical energy is equal to the total work done for maintaining the flow of that electric current through the conductor. So therefore the electrical energy can also be written as, okay, electrical energy E. Okay, the electrical energy can be written as, which is equal to the work done. Then what is the, from this equation we can get work done is equal to electrical power into time. And how much power is being consumed per time gives the value of electrical energy or work done for maintaining the flow through the conductor. And also we know that from the three equations, P is also be written as V into I into P is equal to V into I into T. So the total work done for maintaining the flow through a conductor is the voltage or the potential difference applied, electric current flowing per unit time. So also we can write as, if you substitute the value of V in this equation, so as per the Ohm's law, V can be written as I into R. Okay, then that means what? I into I square RT. Okay, that is another equation for P. And otherwise, if we substitute the value of V, I in this equation, okay, what as per the Ohm's law, we will get I is equal to, this is how we write, V is equal to I into R. Okay, and again, if we substitute the value of I is equal to V by R, right? So that means we will get V into V. V into I can write V by R. Then V into V square by R T. This is also derived from where I is equal to V by R. Okay. So these are the three equations for the electrical energy or the work done for a conductor.